Consumers really love AI because if I ask for an image of a cat on a fire truck, the range of acceptable outcomes is infinite. And the cost, if it's wrong, is zero. If we don't solve this problem as an industry, the vendor lock-in that will exist will be enormous. You need to convince them that your product will create some kind of intellectual property or competitive advantage that they can't find anywhere else. The way that we think about applications is we look to find really unattractive work that a lot of people are either doing, and there's a demographic problem. Example of this happening a lot is like with the BDR role, right? I was talking to the CEO of a publicly traded CRM company, and I asked him, well, what happened to BDRs? And his projection was in the next few years, you might see 2/3 reduction in overall business development reps as a job, because a lot of that can be automated and they can be hard to hire.
AutoSkills helps teams go from AI curious to AI ready. We run tailored workshops to uncover where AI has the biggest impact in your business, whether that's automating repetitive tasks, cutting hours out of your daily workflows, or choosing the right mix of tools and custom solutions. It's practical, hands-on, and built to get your team using AI for work that matters. Book your free 30-minute AI readiness audit at autoskills.ai. In every company exploring AI, one question that comes up again and again is, how do you know which use cases are actually worth pursuing? When LLMs exploded onto the scene, teams rushed to experiment, but few had a straightforward way to separate high-value opportunities from distractions. Which is why this week, I wanted to resurface this conversation with Tomasz Tunguz, founder and general partner at Redpoint Ventures. Tomasz brings a rare perspective, combining his early experience building ML systems at Google with over a decade of investing in data and software companies. In this episode, he breaks down what makes AI use cases valuable, how today's LLM tool landscape compares to the modern data stack, why human evaluation matters, and the distribution strategies that actually help AI products scale. It's a conversation packed with lessons you can apply right now and a perfect reminder of the fundamentals that don't change, even in this fast-moving space. I hope you enjoyed the episode. All right, Tomasz, welcome to the show.
Thanks everyone for having me on. Pleasure to be here.
The pleasure is all mine, and I'm very excited to chat. So as everyone in the audience knows, we host folks that are normally building in the AI space, but Tomasz has such an incredible 10,000-foot view of the space. We thought you'd be a great guest to have on just to give your perspective on the space and the opportunities, the challenges, and what some of the top operators in the space are doing. And so to kick off, for those who haven't met you or aren't familiar with your work, do you mind giving a quick introduction?
For sure. Yeah. So my name is Tomasz. Been a venture capitalist for about 16 years. I was at Google building machine learning systems, primarily in the ad targeting for AdSense. We were using classical methods back then, and studied computer science and mechanical engineering. That's sort of how I got into this world. And I'm the founder and general partner of a firm called Theory. We're 9 people. We're focused on data. We invest in 3 different categories. The modern data stack is one. Number 2 is applications and infrastructure for AI. And then the third is blockchains, which we view as databases. So that's the firm. We've invested in 8 companies so far, and about a half of the portfolios within AI, both at the application layer and infrastructure layer.
Amazing. So you've seen a lot of technological trends as a VC, as an operator prior to your time in venture. And how would you describe how LLMs and the recent wave of generative AI is different than some of the technological waves and trends that we've seen in the past?
The first difference is that the incumbents have an advantage. So we say startups have had negative time to launch because Google and the others have 60% of all the PhDs. They have all the data. They have distribution. So that's one major change. I think that's been talked about quite a lot. I think the second major change is, like, if you think about like the mobile apps, or if you think about the internet, it wasn't difficult technology. And what I mean by that, like, we learned how to build websites. It was very tractable. We learned how to build mobile applications. Implementation, like Uber using the GPS, we needed to learn. But here we have a technology that for the first time is non-deterministic and chaotic. So what do I mean by that? Well, if you ask the same question twice, you might get 2 different answers, and they might just invent something. And that completely changes product design. It completely changes the sales process, because now all of a sudden a buyer has to think about, well, I have sort of this caged animal in a box that most of the time might behave, but sometimes it might lash out, or it might promise a customer something that doesn't exist, selling a card, a price, it's false. And so in that sense, it's a pretty fundamental change in the way that we think about product design. And I would say one of the things we've been talking about internally is how I think we'll see probably two waves of using these applications. And we're kind of in the first peak, and a little bit like Wall Street Journal is starting to write negative stories about AI and some of the challenges. So we're starting to approach the zenith of the first peak, and I would characterize that first peak as we viewed large language models as the solution. In other words, we're building a new product. The product itself is just the LLM. There'll be an input to the LLM and an output to the LLM, the machine learning system, and then that will be good enough. What we are realizing is that's nowhere close to enough, and we need security systems and monitoring systems and classifiers and ways of eliminating the error and the hallucinations that exist that are characteristic of these systems in order to get them to do something. And I think that's what will catalyze the second wave.
Great. Okay, so that makes sense. So there's two waves of LLM development. Right now, people are viewing LLMs as a solution. And I'm curious, what are some of the biggest challenges that you're seeing when it comes to developing with LLMs today? And it might also help if you're able to draw any analogies to the modern data stack and how getting companies to build production-ready infrastructure and tooling in the modern data stack required a whole new set of data tools. And I'm curious, like, if you draw any analogies from the modern data stack to the world of LLM development and what opportunities there might be and what types of tools you're especially bullish on in this industry that'll help teams build more predictability and determinism in the process of developing LLM apps.
That's a great point. There's an almost identical architecture to these systems, at least at a really high level. So in the modern data stack, you would have, like, let's say you have an ATM. People are pulling in, withdrawing money, depositing money. That data is then moved through pipes, data pipes we call ETL layers, just moving data from the ATM into a cloud data warehouse like a Snowflake or a DuckDB. And then inside of that database, there's transformation. So you want to reformat the table so you can show your CEO, whatever it is, withdrawals by geography, by demographic. And then there are three outputs of that from that cloud data warehouse. There's BI, that's a steady state report. Where's my revenue over a certain period of time? And like Looker and Omni are in that category. You have exploratory data analytics. So we have Hex in common, where CEO might ask for an ad hoc analysis. And then the last, and I think what we're seeing now in particular, is the expansion of AI, using that data to feed different machine learning systems. And historically, those machine learning systems have been for post hoc analysis. Let's do a churn prediction and then use that to inform how the customer success team operates. But increasingly, that data is now being used in production systems. So the Netflix content recommendation system is an example of data flowing through analysis and then being put back into production. With large language models, everybody who's using a large language model will have an architecture that looks like that. And so you have data movement technologies, you have data transformation technologies, and then you have databases that then go and serve different production systems. So the data movement technologies there are companies that cut up documents and chunk them, because large language models, they don't look at a Word document or a PDF as a whole. They need to look at it in pieces. And so there's information retrieval systems and different techniques like retrieval augmented generation, graph techniques, or vector search or semantic search. So that's part of that component. Then there's the creation of the vectors, and we use this word embeddings, which has confused me forever. It's like not a native term for me, but basically take all of that information and transform it into a way a computer can understand, so that when somebody says, I want to plan a trip to Paris, the large language model both receives the query and all the documents that are related to it. And there, I think we're very excited about that category. We've invested in a company called Superlinked, which is building a vector computer that allows you to combine numerical data with textual data and in real time update that, which is the key to the TikTok algorithm or the YouTube Shorts algorithm. Then you have the vector databases that store pointers to all the data that might be relevant. And so that's the stack. I think the dynamic that we have is, as we're building this stack in a parallel to the modern data stacks evolution, the org is changing. And AI is stressing the engineering org. Well, why is that? Well, historically, software engineers have never touched machine learning, most of them. And they are deep experts in their own discipline, which is building software and scaling it, being very familiar with infrastructure. But now all of a sudden they have to be experts in, how do I structure data? How often do I need data? And on the other hand, the modern data teams, I'll put myself in here because they invested so many companies in the category. We never needed to build production system. Pipeline goes down, nobody cares. It's not like, whatever, a 5-channel pipeline needs 5 nines of uptime. But now it matters. And so I think where we're going is the AI team, or the people producing the large language models, are being merged or fused into the software engineering team. And there needs to be a common language. The software engineer just wants to hit an API for data. Okay, how does a modern person from the modern data stack actually do that? So there's this fundamental organizational change. And then with that, there are workflow changes, which means software itself needs to change.
Yeah, and so you describe the development sort of pipeline for LLM applications and some of the pieces involved. Now, one of the challenges that is a bit unique, as you described, is the non-determinism of the outputs from these models and these systems. And evaluations has popped up as a term that is somewhat loosely used in the industry, but essentially what it represents is a way to very scalably understand the quality of subjective outputs. At least that's a oversimplified definition of what evaluations and what the function of evaluations are. How do you see evaluations and the role that they play in the LLM development world? And I'm curious if you have any analogs from the modern data stack or pre-LLM technologies that may help us think about what evaluations are and how they might evolve over time.
Yeah, it's a great question. So, as you said, the large language models, they are also less than predictable across versions. So if you upgrade from one version to another, or the underlying data of the same model changes, something like 20 to 40% of the prompts break. That's a problem, because you can't, as a product manager, you can't guarantee a particular kind of experience to a user, and you're uncertain about the overall performance of the system. I don't think there's a great analogy within the modern data stack. The best analogy I've come up with is search engine quality at Google. So, you can put an infinite number of things into a search engine, and for different kinds of queries in different languages with different permutations, you might get very different answers. And then even now we have personalized, for a long time, we've had personalized search. And so Farun, you and I might type in the same query and actually receive different results. And so the way that the major search engines solve this problem is they have some tests, which in the LLM world, we would call evaluations. And some of those tests are performed by machines, where they say, what does a flight cost from New York to San Francisco? It's very easy to quantify. And then there are humans who are responsible for grading the outputs. The challenge with human grading is there's typically only 60% overlap on the same output. Out of 3 humans, 2 will agree. So that's sort of the state of the art. I think every company will need their own set of evaluations, and a lot of times businesses develop what's called a golden set. So these are the evaluations that we care the most about. And those evaluations are context specific. So if a large language model is looking at an income statement, the way that a tax auditor will look at that statement is very different than the CFO of that business, is different from a public markets investor. And so that context really matters, which adds additional dimensions of complexity to these evals. So there's no sort of standard set of evaluations for looking at an income statement. It's really company specific. It's almost company and searcher specific. So I don't think this is a problem that can be solved with technology. I guess is a short answer. This is a human scale. How much money am I willing to spend? If I invest $1 million here, how much ROI am I getting? It's a little bit like software testing. in that sense. I think the big innovation that will come here is in the creation of these tests. Today we create them by hand, and we look at logs, or a product manager might say, I think this is what people will ask, and so we'll create a test. Our bet on the future is that there will be new analytics vendors, and we're investors in one called Context out of Google that watches how users engage with AI, clusters those conversations, and then synthetically creates the evaluations tests that are fed in. And then that way you have this nice feedback loop between analytics and evaluations that's informed by usage. I think that's the way things will evolve, but it's still really early there.
I couldn't agree with you more. I'm very sold on this idea that this concept of auto evaluations and out-of-box evaluations is a bit of a misleading type of, I guess, idea. Most of the time with the companies that I'm working with, their evaluations are extremely context dependent, and rarely have I seen out-of-box evaluators actually be useful for some of these companies. What I have seen go well is human evaluations or human reviews of outputs that eventually are scaled in the form of evaluations. But in the end, what those are very context dependent evaluations. So it seems like that sort of workflow from being very high touch with outputs and then moving to a more automated scaled approach is much more efficient than going with something out of the box and trying to iterate and improve that. Because ultimately somebody needs to get their hands dirty and get very familiar with the outputs and the quality of the outputs as they deem them, with their variety of criterion.
That's right. And, if we don't solve this problem as an industry, the vendor lock-in that will exist will be enormous, because the cost of migrating from one version to another, or a closed to an open source, or vice versa, it'll just be too great. And so the rate of innovation will slow down. So it's really important, I think, as an economy, that we figure this out in a semi-scaled way.
Absolutely. Absolutely. What gets measured gets improved, and evaluations are a great way of measuring how well these LLM systems are operating. So couldn't agree more with you there. So there's a lot of folks out there that are still a little bit bearish about LLMs. And I think they've just been burned in the past with these hype cycles and these technologies that were supposed to be incredibly revolutionary and useful to their business. And so they've gotten to a point where they're ignoring it. And then there's other folks that are very aware about the non-deterministic nature of these LLMs, and they're just a little bit risk averse, and they're going to wait for things to become a little bit more mature and predictable before they actually start experimenting with these tools and technologies. I'm curious what you would say to some of those folks who are bearish, how you think about that perspective, and if you empathize with it at all, and any advice you might have to some of those folks, maybe especially in the regulated industries like healthcare and finance, who are just a little bit reluctant to dive headfirst into using LLMs and trying them out in a sandbox in their company.
I think they have a very reasonable reticence to engaging with these models because of the risks that we've outlined. I will say, particularly with machine learning systems, the way it works is we figure out some new innovation. The models perform at 75-ish% accuracy out of the box. And then it takes us about 10 or 15 years to improve that performance to 95 to 98. And that performance is nonlinear. So what typically ends up happening is the technology industry, as we do, overpromises because we see the future and we want it here now. And so this is the future of work. This is the way that will work. And then there's a little bit of a collapse and then it comes back. So I think it's about matching the use case to the risk. And what we've seen, consumers really love AI because if I ask for an image of a cat on a fire truck, the range of acceptable outcomes is infinite. Oh, what that can look like. And the cost, if it's wrong, is zero. So I think it's a mistake to, if you're in finance or regulated industry, or you are just predisposed not to want to try these technologies, it would be a mistake to ignore them. I think it's really important to understand them and just test, just like play around and see. And we do this internally all the time. I play with different models, and even if the models looks pretty similar, they have different feels, they have different personalities, they do different things. In the late 90s, we all tried different search engines, and we figured out, okay, Google works better if I talk to it like this or type this particular thing. And over time, what we'll see is it will come more and more into the enterprise. It will come more and more into AI, will come more and more into regulated industries, and the quality thresholds will improve, and the trust, because this is basically just a question of trust. So use it with the use cases where it doesn't really matter if it works or doesn't work. And then over time, let the vendors prove to you that there really is trust, but don't write it off, because maybe it takes 10 or 15 years to get there to 80 to 85, 90% accuracy. It could, in this case, I think it could be a lot faster too, because so many people are working on it. And I don't know if it's $1 trillion, but there are definitely hundreds of billions of dollars being spent. You see the cloud, the hyperscalers investing $15 billion each a quarter in building out these data centers. Facebook is buying 20 billion GPUs, $20 billion worth of GPUs this year alone. So there's just a huge intensity. And so the pace of innovation here might be much faster.
And for the folks that have already gotten bought in on adopting LLMs into their products, I'm curious how you think about identifying suitable use cases for those LLMs. That's one of the questions that I run across most often is, all right, this is a really cool technology. I want to test it out, but what is a good framework for thinking about where I can actually unlock the most value for this technology in my business?
Okay, so we'll structure this in 3 different ways. So the first is the implementation. So there's 2 different ways of implementing these AI. There's co-pilot and agents. In other words, sentence completion or full task automation. What we found is that sentence completion accelerates work by something like 50%. That's pretty good. And there's a human that's watching it all the time. So you don't need to have a high level of trust. Full automation is really early. And there are a lot of questions to be answered, particularly around risk exploding through long dated work. The second thing that we look for in applications is if the system is 75% accurate, is that valuable? So let's draw 2 different opposing cases. If I work in a credit scoring team and a large language model gives me a 75% accurate answer on whether or not I should extend somebody a loan of $100,000, that's useless. It's a waste of time. It doesn't give me any new information. But on the other hand, if I'm a creative designer or I need to write a blog post and give me an 80% solution, that's actually really useful because it's a lot easier to edit than it is to create for most people. So which side of the curve? Then the last thing, the way that we think about applications is we look to find rote toil, really unattractive work that a lot of people are either doing and don't like the job because it's not fun, it's not interesting, it doesn't change. And there's a demographic problem. So let me give you 2 examples or 3 examples. One example is long haul trucking. Average age of a long haul truck driver in the US is north of 60. Very few people want to go into that career. That's a great application for AI because driving on the highway between Los Angeles and Chicago, highway doesn't really change. It's rote toil. And a machine learning system can do it probably safer than a human. Another example of this, and this is happening a lot, it's like with the BDR role, right? I was talking to the CEO of a publicly traded CRM company, and I asked him, well, what happened to BDRs? And his projection was in the next few years, you might see 2/3 reduction in overall business development reps as a job because a lot of that can be automated and they can be hard to hire. Another category, and we've made an investment here, is in security analysis. So if you're an average enterprise, you have 75 different security products. Each of them spits out alerts, goes to a team. It's called Security Operations Center. Average enterprise receives 8,000 alerts a day. Less than 1% are reviewed. It's really tough for a human just to keep reading messages and classify them. But the machine learning system is really effective at doing that. And that's this business drop zone. We were looking at companies in the accounting space. There, the average age of an accountant is 59. Few people are getting into the industry. And so there, again, there's a lot of repetitive work, primarily around document ingestion, W-2s, 1099s, all slightly different formats. How do you put that into a tax software? So rote toil, where there's a demographic shift or a labor market shortage, those are areas where, and then the accuracy, you have the benefit of an 80% solution is accretive. That's where we think at least the current instantiation implementation of AI works pretty well.
So just so I'm hearing correctly, is rote toil?
Yes, rote toil.
Rote toil. That's funny. I think a couple of interviews ago, I interviewed Daniel Doyen, who's a co-founder at Readwise, and he had a very similar concept, although it was worded slightly differently. He called it bullshit jobs. So they essentially look for what are the bullshit jobs that they want to essentially automate using LLMs, but similar concept, just different phrasing of it. So that's a very, very helpful framework, and I appreciate you digging into that. And specifically from an industry level, which industries do you see as being the most ripe for innovation? You mentioned sales, so there's a lot of rote toil in sales that is slowly, or well, actually rather quickly being automated away. Any other industries that you're keeping an eye on or are particularly bullish about?
Well, the two first industries, one was software writing, right, with Copilot. The second one has been legal. Those are the ones where most of the initial finance, and then marketing copy. Those were the first three. We're starting to see now a lot in financial analysis, research of different companies. We see quite a lot in the accounting space. There's a collection of 50 or 60 different robotic process automation. And that's a fancy word that basically just means reading documents and then putting the document data into some kind of a CRM or an ERP system. Those tend to be, at least initially, probably the 6 categories where we've seen the most innovation. There's some in the data transformation, data pipelining tools, and then security is starting to happen. So we've seen a wave of financings of the generative AI-enabled security businesses. Yeah, I'd say those are the 7.
Got it. So I'm going to pivot just very slightly here. Very early on during our conversation, you said that one of the things that is interesting about this new wave of LLMs is that incumbents have a very strong advantage. And I like the way that you phrased it. Startups have almost negative time to launch, or they have negative time to launch. What advice do you have to incumbents in order to capitalize on the opportunity at hand?
Well, I think Microsoft's doing an excellent job. I think last time I estimated their business in AI, it's about 5 billion run rate in 18 months from zero. So I think they're doing a really nice job. They're infusing all of their products, both you've seen the Microsoft or the Windows laptops that now have AI keys. Apple had their AI launch. And so just infusing every product and charging a markup on that is dominant strategy. I think in the next wave, what we'll see is a linkage between the software and the hardware. So what do I mean by that? Well, these machine learning models are really expensive to run, especially the big ones. And right now, when these models run, they typically run in data centers on GPUs that the major technology companies buy or rent. But within my laptop, there's a phenomenally powerful GPU. And within my phone, there's also very close to an equally powerful GPU. And so I think under the guise of like privacy or data control or data ownership, you'll see these major cloud companies start to push models to the edge, to the devices. Google's already doing this with Maps. Apple's announcement was basically entirely about this. And the companies that have a combination of a software product plus a hardware product will have a huge competitive advantage relative to their peers because their gross margins will be better. They're not paying for as many GPUs. They can give you a better performance, and they can spend more on cost customer acquisition and generate more revenue. And so I think you'll see a lot more if you're a company that doesn't have a lot of hardware. Google has a little bit of hardware with their Pixel devices, but they don't have laptops that scale aside from the Chromebooks the way that Apple does. You might see Google partner with Samsung in a pretty meaningful way on that kind of hardware acceleration or create toolkits to do that. I think the other thing that's really important for these incumbents is to support as many different model families as possible. The last time I looked, Microsoft supports 50 different models. You really want to be the place where all the data is stored, all the compute happens, and then applications are built on top. One dynamic that we've observed that I don't think has had enough press coverage is 5 years ago, we took for granted that if you were a startup, you were building on Amazon. Today, you're probably building on Azure. You're probably building on Microsoft because, real or not, there's this perception that if you're not on Azure, you'll probably receive slower access to the very best models. And so that, I think, is critical. And that's why you need to support as many different fund families. The strategic relationships between the hyperscalers and the LLM creators becomes super important.
Yeah, it's been incredible seeing the turnaround at Microsoft and kind of the domination of Microsoft in this industry. And what about some of those incumbents like the intercoms of the world? I guess you could call them incumbents, even though they are uh, they're not sort of at the scale of Microsoft, but a lot of companies that are being bombarded with new competitors and upstarts that are AI native. Do you have any advice as to how they can leverage their data moats in order to build a advantage that essentially expands over time?
So what I'd say to them is, at least for now, we haven't seen many buyers of software switch for AI. We haven't seen a lot of shift. There's this window where even launching a modest AI product will allow you to increase your ACV. And so I've heard a couple of different stories where the AI product doubled ACVs, just like they just doubled the price per seat with this additional feature, and businesses surged using the existing distribution. I think that's the strategy that you'll see for the intermediate term. And so AI in and of itself is not enough to switch. But what could be? The hypothesis we're currently working on is buyers have become wise to the value of their data. We've all seen Google create the very best business model on the internet by siphoning everyone else's data, building a machine learning system, and commercializing it. And so today, buyers are saying, or enterprise buyers are saying, actually, I want control of my data. I want it to be on my cloud, in my VPC, and I want the application to come to me. And then when I stop using the application, my data remains. And so we think there may be an architectural shift that we call cloud prem, where the software companies that typically store all the data in these multi-tenant huge databases need to re-architect. Snowflake is facing pressure here. In the last quarterly earnings, they talked about Iceberg, which is a technology that allows companies to keep their own data, and then query engines like Snowflake to hit that data. And I think we'll start to see that at the application layer much more broadly. That will take some time. It may take 3 to 5 years to get to that place, but buyer preferences have changed. Apple is positioning itself as the privacy-focused AI company, and just as they're pushing in the consumer, that will impact enterprise. And so that's, if I were a mid-stage or mid-size software incumbent architect as a multi-tenant software, I would be worried about cloud prem.
Okay, so let's flip the script a little bit to startups. So if you're exploring new startup ideas and you want to disrupt a specific industry with a AI native startup, how would you think about setting up so that you're maximizing your odds of unseating an incumbent in that particular industry?
I think the thing that will separate the next generation of companies if there's an existing incumbent that's founded in the last like 7 to 10 years, launching an AI feature is not enough. I think you need to convince them that your product will create some kind of intellectual property or competitive advantage that they can't find anywhere else. Well, what could that be? You keep your own data. We train particular models. Those models materially increase your revenue or materially decrease your cost. It has to be one of those two things. And the other dynamic that's really important is we will not replace huge swaths of your employee population, because that's still a significant blocker. The last thing I'd say is most enterprise buyers are still figuring out their AI purchasing policies. How do we want to be architected? Are we comfortable with AI in the cloud? Are we not? And so being able to educate that buyer base and having a variety of different deployment options will be essential to nullify some of those objections.
I was listening to one of your interviews on YouTube, and you mentioned that you had a grad school marketing professor who shared a equation that stuck with you. It's essentially innovation equals invention plus distribution. And you talked about how as the cost of invention goes to zero as a result of generative AI, distribution becomes much more important. How would you translate that into practical terms for companies and how they should think about how the importance of distribution changes in an AI-driven world?
So Gartner published a study, cost of customer acquisition for software companies has increased 60% over the last 5 years. Monotonic, goes up every year. So what does that mean? Well, 5 years ago, if we invest in a company $10 million, well, they can buy a lot less business today with that $10 million or than they could 5 years ago. And so what that equation tells us is, well, a small but compounding advantage in the cost of customer acquisition will give you disproportionate market share. And in many software markets, you have some markets where the markets are equally divided, like the first wave of mass email providers, Constant Contact, and that whole group. Most of the time, the winner gets about 50 to 60% of the market. And if you can be that winner, you're probably 2 to 3 times the size of anybody else. So what really matters is you have some technology innovation that creates a go-to-market advantage. All of a sudden gives you a lower cost of customer acquisition. It could be the use of open source. It could be leveraging YouTube. It could be word of mouth. It could be any number of different things, category creation. It could be any number of different things, but in order to be the category winner, you need that cost of customer acquisition advantage. And so figuring out what that is and then driving a truck through that opportunity is how you win. And it sounds very simple, but it's incredibly hard. I had the bias the other way. So when I started in venture, I came from Google, and Google is often thought both internally and externally as a company that led with its technology. The reason why it's won is its technology. What's not understood is, in fact, like Google signed a whole bunch of really awesome distribution deals to be a browser plugin, a little toolbar in those days. And then they embedded themselves in websites everywhere, and they really solved the distribution problem. And the distribution gave them access to more data, and more data, as we know, more data improves machine learning systems much, much faster. And so now, we place a lot of emphasis, much more than I have in the past, on the distribution of a company and that distribution strategy. So that's where I spend a lot of time.
Are there any particular businesses that you would say have stood out to you as having found success in building that data flywheel through a unique distribution strategy early on?
In the AI world, I think, the thing that I admire about Midjourney was the distribution strategy. So Midjourney is distributed through a chat app called Discord. You don't go to the website to use it. You go into a chat room, and then you type in a bunch of instructions. And initially, I thought it was crazy. I thought, what? Why would you do this? But there's brilliance there, which is, one, the chat room platform, Discord, is growing really fast. 2, this is a brand new technology where most people don't know how to use it. And in fact, the creators themselves are learning how to use the product. So there's no manual. And so by publishing or by engaging with it in a chat room, everyone can see what everyone else is doing. Everyone's experimenting in public. And so Haroon, like, you might decide, oh, I'm going to try vector art. And I'll say, I'll try an anime style. Let's do a watercolor or photorealistic, or let's type in some of the attributes of a camera that might take this photograph. And that knowledge builds on itself. I thought that was a really brilliant product design or product delivery strategy that really helped that company grow.
That's a great example. I think Midjourney was the reason that I even signed up for Discord in the first place. I had many reasons to sign up for Discord before that, with all of the communities that are being built there, but I always ignored those. I ignored those for the most part until Midjourney, and I thought it was just so cool how you could leverage this powerful AI stable diffusion tool directly in Discord. So yeah, great example. So as this technology evolves over time, I'm curious how you see this landscape evolving in the next 5 years. Even feels too long, but the next 1 to 2 years. And particularly, one thing that I am curious to get your thoughts on is, we know that non-determinism is more a feature than a bug, but it also creates a lot of additional considerations when you're developing using this tooling. do you see the process of AI product development becoming more deterministic over time, or do you think we're just going to find ways of dealing with the non-determinism in different ways without adding more determinism into the process? So I'm curious to get your thoughts on that, and then more broadly on how you see the landscape evolving in the next year or two.
Okay, everyone. So imagine I'm just out of college and you hire me as an intern. So Tommy T, the intern. And you tell me, hey, I really want you to write an article about the future of AI. But I'm just going to tell you, I want you to write an article about the future of AI, and I want you to work on it for a month, and then come back to me. How good do you think that article will be? It will likely be pretty terrible, right? Because if you don't really have a lot of sophistication and you don't have a lot of context, you probably make a little bit of an error here in the first week, and it'll compound, and all of a sudden I'll come into you. So I have this amazing piece. And I think this is sort of, as we think about multi-step large language model applications, this is kind of the current design where the error rates are 20% at each step. And we know error rates multiply. And so pretty quickly, just like Tommy T, the quixotic intern on a journey to create this beautiful post, the large language models will just end up in a place where it makes no sense. So what we need to be able to do is we need to be able to control those error rates. So we need to constrain the inputs, and then we need to constrain the outputs. And the way that we're imagining, I'm not sure if this will ultimately happen, but the way that we're imagining it is the large language models are producing suggestions. And then there are classical machine learning models that are saying, this is a valid suggestion, this is not a valid suggestion. And in that way, the error is created and then quashed. The error is created and then quashed. The error is created and quashed. And that can be with like classical classifiers, like is this a dog or a cat? It can be with adversarial techniques. So you could have two large language models. One is the suggester and one's the critique. In other words, writer, editor at each step. And there'll be different configurations. But earlier we were talking about those two different waves. The second wave of the systems will be characterized by something that looks like this. And once we get those systems working, they will be able to perform much more complicated tasks that take longer with less direction. And that's where we get the leverage, right? Today, the human auto-completing a sentence in Copilot is pretty useful. It saves 50% of your time. On an assembly line for building trucks or cars, robots replace about 2.5 to 3 people, right? So 300% the productivity. And where we really see big impact to GDP or true long-term changes in these much more complicated systems that need this quashing of error at each step.
Yeah, that's a great call out, and definitely a difficult challenge that we'll need to figure out how to address. The thing that makes me hopeful is we're starting to see agents in prod, and broadly speaking, the techniques that these teams actually like Hex, we interviewed Brian at Hex a few weeks ago, are using is very similar to how you described. And so we're moving in the right direction there, and very excited to see how we can build more complex applications, agentic applications, and in production over the next year or two as well. I'm curious how you see the relationship between us and AI evolving over time as well. And so SDRs and the role they play in the sales process, I think is a good example to maybe anchor on. How do you think our relationship with AI is going to change as professionals in workspaces, specifically, not necessarily outside of the workspace, but as professionals, how do you think we're going to interact with these tools and technologies, and how's that going to evolve over the next year or two?
Let's take the sales process as an example. Buyers will be much more sophisticated coming into the buying conversation. Why? Because they'll take all the materials about a next generation CRM vendor, upload it into LLM, and then pepper it with questions. Much more comfortable to do that than to get on the phone with a human. And so they'll have they'll have really deep knowledge and insight, and they'll have some pretty good sophistication. Yeah, I did this with HubSpot versus Salesforce, and I put it into the LLM. And it said, actually, it recommended you should use HubSpot because you're a small business. It's a better fit. So I think we'll see a lot of that where AI engine optimization replaces search engine optimization because these systems recommend. And then the buyers themselves become more sophisticated and people learn with AI. It becomes a tutor for literally anything that you might want to know. On the sales side, the antidote there is that the scale of the activities that a BDR or an account executive can accomplish will probably go up by somewhere between 100 to 1,000x. And it's not limited by the AI. It's limited by the email platforms where Google is saying you can only send 50 outbound emails a day. That's the limitation. And so I think we'll get to a place where we'll be much more educated, and then people will be much more leveraged. And so the human-to-human connections will be better informed, and ideally conversion rates increase and the efficiencies of these businesses overall increase. We did this analysis in a blog where we were trying to figure out, does the gross margin of a software company increase in 10 years or decrease in 10 years because of AI? On one hand, it decreases because the machine learning models themselves are super expensive to run. On the other hand, engineers should be 50%, at least 50% more productive. Salespeople should be more productive. And then the pace of the business. So overall, we netted out, this actually meaningfully improves their gross margins. We didn't want to put a number on it, but we thought like on the whole, maybe 5-10% gross margin improvement. But we'll see. That's just a guess.
Tomasz, how do you keep up with the just fire hose of information that is being shared in regards to AI and some of the developments in LLMs and technologies in the space? I'm curious, like what you're reading or any resources you might recommend.
So we have an incredible team. So that's first and foremost, and we all spend a lot of time researching. The other things I do, I will take the new papers and put them into Claude and then ask questions of Claude about the paper. I don't know about you, but it's a really dense format. And then comparing and contrasting two papers, large language models are actually pretty good at doing that. And then the last thing that we do is we use a lot of them internally. So we will try, like we've been summarizing our calls for an awfully long time. We deploy models to create investment memos and write blog posts and try to fine tune them and just see, because if you can, and then you get a flavor like, okay, the the small language model, this is what it's really good at. It turns out that Llama 3 is not that good at summarization. And if you paste a link into Gemini, it spits out a whole bunch of stuff in different languages. And so you kind of get a sense of which models are really good at what things. And then you also get a really good sense of, okay, I could imagine using Claude to do pitch deck summarization because, in fact, like it does a really nice job on papers, but I probably wouldn't use ChatGPT 4.5 for that because it's actually much better at code completion. And so there are these I think like figuring out the personalities of large language models is fun.
Well, Tomasz, thank you so much for taking the time. Where can people find you and learn more about Theory Ventures and all of your very interesting thoughts and opinions about the AI space and also just investing abroad?
Thanks for having me. TomTunguz.com is where I publish our posts. And then theory.ventures is our website.
Tomasz, thanks so much for joining the show.
Such a pleasure. Thank you very much, Arun.
AutoSkills helps teams go from AI curious to AI ready. We run tailored workshops to uncover where AI has the biggest impact in your business, whether that's automating repetitive tasks, cutting hours out of your daily workflows, or choosing the right mix of tools and custom solutions. It's practical, hands-on, and built to get your team using AI for work that matters. Book your free 30-minute AI readiness audit at autoskills.ai.